Hello everyone, this is the last video about this controller. Um, Here I'm going to look at to replace the unknown microcontroller uh, with an Arduino. Let's look at how we can do this. First of all, we need to remove the microcontroller from the board. I'm going to remove the insulation layer first. I will use a screwdriver to lift it up. After that, I need to desolder all the connections to the PCB using soldering iron and the sucker. It is a little time-taking task. I put a small screwdriver to lift the microcontroller a little. And still some bit of soldering exists, that's why it is difficult to remove. And I'm going to iron it out using this copper wire and take all the soldering out from all the pins. And now I think it will everything is fine, and giving a little lift, I should be able to remove it little easy. Yeah, yeah. I little clean the whatever the soldering and dusts. After that, I connected a ribbon cable to with all the wires that should be connected to the microcontroller, and I need to solder it carefully. I'm verifying the connections to the each cable with the note I prepared from the controller testing in the previous video. And after that, I use the glue gun to give some insulation again from water, because some rust may be building up if this needs to perform a long time operation within a washing machine. Therefore, I'm putting some glue on top of each wire. I need to do this onto the other side of the wire as well, and also I will do the same to the PCB bottom of the PCB. This is the power connection. I'm putting some glue around it, and also the microcontroller connections also need to be better to have some glue around it, those pins also. I have already attached the pin header to the other side of the wire, and I'm connecting the to each connecting that to the Arduino, and now it is ready for operation with the test circuit. The test circuit for the test program I built is just to switch on and off the one of the tracks with a simple controller, simple program. After testing it, I'm going to move into the main program for the washing machine controller. In this design, I use Arduino's digital pins from 8 to 13. Okay, now let's look at the Arduino Sketch now. All the pins connected to all the actuators with the color codes, and only one input is taken, which is the start button. And when we press the start button, default number of wash cycles are 2. If you want to increase the wash cycles, you need to keep press and hold the start button. In that case, number of wash cycles are getting increased. And there are no sensors in this controller design. Everything is controlled via the timing. Therefore, all the delays are defined, and there's a setup to configure all the inputs and output of the Arduino. As you see in the loop, it is by default taking the default wash count. If the start button is press and hold, it will increase the wash count. Then it will go to this loop, and it will stop all the actuators and take the water in and do the wash for 8 rotations, clockwise and anti-clockwise. After that, rinse happen, and after all the wash cycles are complete, spin happens, and there are 10 beeps at the end. That is how the code would look like. I switched on the washing machine controller here. Now the Arduino is powered up, and now washing machine is ready to start. I need to press this button for a while so that I can hear the number of beeps, so that the number of wash cycles can be configured from that.